Hey, what's going on, fellow neuroimagers? Today we're going to cover a cool tool called Heudiconv, output by the NiPi community, whose main developers, and I'm sorry in advance for butchering your names, Yaroslav and Matthias. So, with that said, I'm going to assume that you have Docker installed already. If you don't, there are some nice resources that you can find that will walk you through the install process depending on whether you're on Mac, Windows, or Linux. So with that said, I'm going to get started here with the first command that we need to run, which will be docker pull. So let me write this out. Docker pull NiPi Heudiconv. And so if it's not already the most up-to-date version, it'll download. I guess specifically we should pull the latest one. That colon notation means that we're going to pull a particular tag, and the tag that we're pulling from is the latest. So if they had different version tags, we could put 0.5.0, depending on how they versioned their particular Docker container. So if I type this out, it should already be up to date for me. So it says it's already up to date. So now we are good to start actually converting our DICOM data. So if I hit ls here just to see what we're working with in our directory, I have two directories and a file. So the first directory is 102, and that one's going to contain all of our DICOMs. So it's in scans. I can go to 2, DICOM, and there's just a bunch of DICOMs there. Okay. And right now in our bids directory, which will be our output directory, all I have is a code directory within the bids directory. So now the actual commands that we're going to use are a bit verbose, so they take a bit of writing. So I actually wrote them down in advance, and I'll copy and paste them into the terminal, but I will explain them in hopefully totality. So the first command that we're going to run in order to get Heudiconv to work for us, we are going to run docker, and this --rm means we aren't going to modify the container. If there are any modifications made to the container while it's running, it'll discard them at the end. And this it means that we're going to be running the Docker container in an interactive manner with a pseudo terminal type deal. And these -v commands are mount commands, so a Docker container doesn't have access to anything that's on our local computer unless if we tell it to have access. So this -v says I want to mount this directory, this Heudiconv test directory, the directory that we're in, to a root directory called data in the Docker container. And this means read only, so it won't be able to write anything to that directory. And we have another mount point, which is the bids directory, so that's where we're going to put our output. And appropriately enough, we can pin that to or mount it to this root directory in the Docker container called output. And finally, we're going to specify the actual container that we want to run, which will be the NiPi container. And within all the subsequent arguments following this will be arguments that are actually being passed into the entry point to the NiPi, or to the Heudiconv converter. So when we look at this first argument, this -d, so we're going to pass in the DICOM data in terms of the general pattern that they follow. So this data is actually referring, this data folder is actually referring to this path within our actual computer. So we just need to translate that out so that we can understand that we're going into a subject directory, which I'll pull back the terminal here. So subject directory meaning, oh, we got 102. And we can pick a particular session. So again, if I cd into 102, let me clear. Then I have these two numbered directories, which will count as sessions. And then within each one, there's scans, and there's a bunch of numbers, 1, 2, 3, 4, 5, depending on the actual scan number. And then within that scan number, there's a folder called Heudiconv, and within that folder are the actual Heudiconvs. All right. And now we can substitute specific subjects, so sub 102, and that'll go right here. And then session, we'll pick one of the sessions, and that will be replaced right here. And finally, I guess not finally, then we specify what function we want to apply. So this will convert all. So for our first run through, this is just going to create information about all the Heudiconvs that are available within that directory. And the converter that we're using is nothing, so we're not using converter right now because we're just trying to get information. Then the output is going to be in this root output directory, which again is going to be inside our bids directory. And specifically, it'll output in something. It'll output in a dot directory called, appropriately enough, Heudiconv. So, I think when we output that, we will be able to look inside that folder and find the heuristic file that this command will generate for us. Okay. Let's see if the copy paste works. So to run, looks like it's successful thus far. And so yeah, this tool will be great to use for all the data sets that you weren't able to save on XNAT or RPAX with useful, more bidsy information, but you still want to utilize bids in your analysis. So this will make the translation a lot easier. So again, it's output in a dot directory, so we can't see it with the regular ls. So I have to do ls-a, and you can see the dot directory, Heudiconv, and we see our specific subject, and I can cd into the info, and now we have a bunch of cool looking files. I'm actually going to pause the video here to make sure that we don't see any potentially revealing information about the subject in the Heudiconv info file. So I'm going to hurry up and delete some of that information. Alright, and we're back. And all the information should have been cleared, so we should be good to open up some files. So open up Atom here, and click on Convert All, and this is the heuristic file that we will be creating, or modifying, in order to do our own analysis. So first thing that we're going to do is that we don't need, for at least for this particular study, we don't need to create any metric for run. So I'm going to delete all of that since we don't need it, and I'm also going to delete this. So what essentially this info to dict sequence is going to do is that's going to look for each sequence that's in our Heudiconv folder, and it's going to look up a certain number of attributes that each sequence can have. And so we can look at the dimensions, the TR, the TE, the protocol name, the series description, and a lot of other metrics in order to specifically identify a particular scan. So in order to get a reference of what these values are, I'm going to click on the TSV here, and that's a tab. All right. Open that table editor. Okay. So we can see that the total number of files that we can check for each of the scans are listed right here. The series ID, the DICOM, dir name, the dimensions, the TR, the TE, the protocol name, and the protocol name is what I'm going to be using for transferring the files over. And yeah, another information. So I changed the age and the sex so that we wouldn't be able to tell that information. But yeah, you can use all this information, the sequence name, to localize specifically a particular scan that you'd want to transfer over to BIDS. And so I'm going to close out of this, and I also made the heuristic file a very simplistic heuristic file. I'll add in order to do that conversion process for us. So I called it convert packer. So what we need to do under this definition of info to dict is that we're going to create a bunch of keys. I could have simplified this a bit, but I'm just going to be as simple as possible here. And for each type of scan that I would ever think about collecting data from, I have a corresponding entry for that. So I create a key for this T1 weighted low res, which is going to be then output into this format, which if you've read the BIDS manual, this should be in this should be a valid BIDS name. And so I'll do that for each of the different scans that I've collected, each one creating a valid BIDS name. And then I'll take all the keys that I've made and put them all into a dictionary called info, and each of these will eventually be filled with a DICOM sequence. So it'll know that all the DICOM sequences that fit within here are going to be transferred to a BIDS directory using this key template, and same for the high res, and same for the T2s, and so on and so forth. So again, this is a very simplistic one, simplistic heuristic that could be improved upon for checking if the number of files is correct, if the TR and TEs are actually what we would expect, if the dimensions fit within our reasonable metric, even the image type to see if that fits in with what we would expect it to be. But I am just using the protocol name, which is a very simple heuristic that I'm going to be using. So I just have a series of if statements all in Python for accessing the protocol name for this S in sequence info. So each S again is a particular sequence. So I'm going to check the protocol name for a particular sequence and see if it's equal to mprage space grappa2, and then I will feed that into this feed the information to the info dictionary. Then I'll do the same for the axial T2 flare if the particular sequence is equal to that, and I'll do that same if conditional for all the protocol names that I have available for me. So again, you can get as fancy or as simple as you want. I just chose a really simple one for an example here. So that would be look more obvious about what we are doing. All right, so if we've made that heuristic, then running the actual command to transform some DICOMs into an actual bids data set is essentially running the same command that we did to generate the heuristic file that we started out with, except we're going to change the converter to DCM to NIAX, add the bids flag, and we're going to change our heuristic file to the one that we made. So instead of convert all, we're going to do convert packer. So we'll see how this one works. So it looks like it's running, so now it might be converting the files right now. I think I'll pause the video so you don't have to watch the conversion process for all of them, since it might take a little while. Alright, and now it looks like we've finished with the processing of converting everything to bids. So we'll take a look at the actual output to see if everything was created as we expected. So here's our new newly formed bids data set. We can see a lot of things have been added. It used to be just the code directory, and now we have a changes, data set description, participants, a README, and a couple JSON files for the functional scans. So we can just explore around a little bit to see what's been given. So the DCM to NIX outputs a lot of information about the different metadata that is typically lost when we convert from DICOMs to Nifty, and puts it into this helpful little JSON file. And we'll see that information again when we cd into sum02. And we can see it says sesh, let's look at that again, sesh dash the number of the session folder that we have. So I can cd into sesh, and we have a scans folder. Yeah, okay. There's a ran string. Okay, I was wondering what all those weird strings at the end were there for. But yeah, so we have a TSV that specifies the name and relative location to this directory of the files. So that looks good. So if we cd into the nat folder, we see that we have all the anatomicals and their associated JSON files. And I can cd into DWI, and looks like we have the actual diffusion weighted images, as well as the b values, b vectors, and the JSON files. So all the metadata that we need associated with it. And finally func. And we have the Nifty files, the JSON files, and it even gave us some events, which we won't need any events for our resting state scan, but let's see what it gave out for us in the flanker task. So we have onset duration, trial type, response time, stem file. All right, and it just gives us a nice little template to fill out those columns with the actual data that we've collected for that task. So we've ran the command and did everything for that particular session, and now we can even run that same command if I go back far enough, and we can run it for the other session as well. So just to remember what that other session was, I'm going to copy this. Then go back again to the command that we called. Get rid of this session. And we see that it should work just the same. So again, I'll pause the video because it'll take a little while for it to finish. Okay, and now it's finished running that as well. So we'll cd into bin, see what's changed. So if we now cd into the subject, oh, it looks like we now have 2 session directories. Oop. Need to specify 03. Okay. And it looks like it's darn near identical except for the session being changed. So we have all the files there that we would expect, because in that session we collected the exact same type of data. So it should be all mirrored except for the date that we collected the data. And so it looks like it converted everything to a darn near close looking bids data set. All we need to do is fill in some of the blank spaces in our dataset description, which is filled with a bunch of to-dos, and filling in the events files, or deleting them if we don't need them for our certain functional acquisitions. So with that, you should have the basic tools and hopefully feel a little bit less intimidated with Heudiconv and feel capable of generating your own heuristic file, whether it's as simplistic as mine or as advanced to be able to accommodate other situations in which you might have failed scans that were still uploaded, or several runs of a certain scan type sequence that you would like to more intelligently collect. Yeah, you can do it as complex or as simple as you want with the heuristic file. And I think that's all I wanted to cover for today's video, so thank you for listening. There will be some slides associated with this so that you can copy-paste the direct commands that I used, but you still probably have to edit them so that it'll work for you, but at least you can have the command structure so you can use that to help. Alright, thank you for listening.